Hello students, how are you? Let's discuss electricity, our next chapter in physics. What is charge? We will discuss first. It is deficiency or excess of electron on a body, and it is a scalar quantity. It can be positive or negative, two types of charges. As we know that positive charges or like charges repel each other, and unlike charges attract each other, right? One charge is equal to 1.6 into 10 to the minus 19 coulomb. 1.6 into 10 to the minus 19 coulomb. You have to remember this. Okay. Now we will discuss types of electricity. Electricity are two types: static electricity and current electricity. When charge is not moving, then it is called static. Static means charge is not moving. When charge is flowing from one end to other end, that is called current. Current electricity. Clear? Electricity, two types: static and current. What is a conductor? First we will discuss what is a conductor. Conductor means which can conduct. Which can conduct. What it will conduct? It will conduct the electrons. It can flow. The flow of electrons can be possible there. These are the substances which have negligible electrical resistance. That is called a conductor. Electrical resistance. What is resistance? Resistance means which resist. Clear? So what are conductors? All metals like copper, silver. Silver is the copper, silver. Silver is the best conductor. Clear? Next one is resistor. As I said that resistor means which can resist. These are the substances which have comparatively high electrical resistances. Means they can resist more. Like when we are going on a road, humps would have been there. You can see humps. Humps are there. Why humps are there? They are also called speed breakers. Means they can break the speed. When a vehicle is going on that road, the speed of the vehicle can be decreased, will be decreased. That's why it is called speed breaker. Clear? Resistor. Resistor acts like that. Means they will slow down the flow of charge. Like alloys. Some alloys like nichrome, manganese. Okay, nichrome is used in electrical irons, heating effect. All heating devices we are using nichrome. Next one is insulator. Next one is insulator. First one is conductor. Second one is resistor. Conductor. Then resistor. Then insulator. Insulator means what? Which cannot allow charge to flow. They are highly, very high resistivity power. They cannot allow any charge from flow from one end to other end. Like wood, rubber, they are called insulators. Clear? Now we will discuss potential difference. Potential difference. Potential difference. What is potential difference? Potential difference is between 2 points in an electric field defined as the amount of work done in moving one unit of charge from one end to other end. That is that we can write potential difference PD. In short form we can write PD is equal to work done. Okay. What is the work done they are doing? Charge, flow of charge. Charge transferred from one place to other place. We can write like this: transferred. Charge moving from one place to other place, work done by charge. We can write like that potential difference is equal to V is equal to work done means W, as we know that W charge is equal to Q. We have to remember this formula. This is very important. First formula, V is equal to W by Q. From here also we can find out W is equal to V into Q. W is equal to V into Q, VQ. Clear? Its SI unit is equal to volt. SI unit is volt, capital V. Now, what is electric current? It is the flow of electric charge. Already I told you, it is a flow of electric charge in a conductor from one end to other end. That we can write I is equal to Q by T. What is I? I is equal to electric current. What is Q? Already I told you, charge by time. This is another formula. We have to remember this. Clear? If we will understand if we can remember and understand the formulas, then it will be helpful to us. Charge by time. I is equal to charge by time. What's its SI unit? SI unit is ampere. SI unit ampere. AMP, you can write AMP. Now, what is a circuit? Electric circuit. Electric circuit means it is closed and continuous path consisting of connecting wires and other resistors and other things like switch. It is a closed circuit like this. One battery would have been there. Okay. Then you can say it is suppose it is a ball, and we have to remember the symbols. Like this is a ball. We have to attach a key. Okay, the open key and closed key, that is in the NCERT book. We have to refer that. Clear? Next one is Ohm's law. Very important. This might come in your exam. Ohm's law. Ohm's law. Very important. What is Ohm's law? Ohm's law gives us the relationship between current and potential difference. What is the statement of Ohm's law? According to Ohm's law, at a constant temperature, the current flowing through a conductor is directly proportional to the potential difference across its ends. You can write I is directly proportional to V, or V is directly proportional to I. Same thing, V is also directly proportional. We can write like this: V is directly proportional to I is directly proportional to V. Means if I will increase, voltage also increase, current will increase, then voltage also increase, potential difference will also increase. Same thing, voltage increases means potential difference increases, means it is current also increase, as we know that. Okay, we can write like this: V is equal to R into I. What is R here? R is a constant. It is called resistivity constant. This is another important formula we have to remember. V is equal to R into I. What is R? R is equal to resistivity constant. Okay, clear? This is resistance. What is resistance? The opposition. Already I told you, resistance means what? Which resist. The opposition offered in the flow of electric current is known as resistance. Mathematically, we can write like this. From here also we can find out R is equal to V by I. V is equal to R into I. R is equal to V by I. Clear? I also we can get it from here, from this equation. If it is equation 1, first formula, this is second formula, third formula also we can deduct. I is equal to V by R. Clear? This is Ohm's law. Clear? This will come in your exam. Definitely some numericals will come from this. Clear? Now we will discuss resistance. What are the factors affecting resistance? Four factors affecting. First one is length. Length of the conductor. What are the factors? So, I will erase this one. Factors affecting resistance. Factors affecting resistance. First one is length of the conductor. Length. If length increases, resistance increases. So R is directly proportional to L. Okay. Second one is area. If area of the cross section, if area of the cross section increases, then resistance decreases. So R is inversely proportional to A. What is the area of the cross section? Suppose this is the wire, this is the conductor, this is the area of the cross section here. If this will increase, then the resistance will decrease. Clear? If the thinner wire, then resistance will lesser. If the thicker wire, then resistance will be, it is inversely proportional. If it will increase, it will decrease. If it will decrease, it will increase. The resistance will increase. Next one is temperature. Third one is temperature. Temperature also matters. Temperature is also directly proportional to R is directly proportional to T. Resistance is directly proportional to temperature. So if temperature increases, resistance also increases, and vice versa. It will decrease means it will also decrease. Okay. From here, this is equation 1, equation 2. Next one is nature. Nature is actually independent. Nature independent means what? Nature of the material of a conductor means, suppose we will take copper. Copper is having definite resistivity, and as well as if we will take nichrome or we will take another conductor, then it is having different. Suppose I will take iron, so they are having different. Is it clear? So they are independent. So now we will find out from this equation 1 and equation 2, we will get resistivity. Okay. What is resistivity? Already we know that R is directly proportional to L, R is inversely proportional to A. So we can write here R is proportional to L by A. Combining this equation 1 and equation 2, we will get R is proportional to L by A. R can be written like this: R is equal to rho L by A. Clear? What is rho? This is symbol rho. Rho is resistivity. It is resistance. R is equal to resistance. It is rho is resistivity. Resistivity. Clear? Where rho is a constant is known as resistivity of the conductor. Its value depends upon the nature of the material, as already we discussed. Clear? So from here also we can find out what is rho. Rho is equal to, if we will take this one that side, then this will A by L. So this is another formula we have to remember. This is R is equal to rho L by A. Rho is equal to resistivity. If we want to find out resistivity, resistance is fixed. Okay, but here resistivity. So this is the formula RA by L. Clear? Resistivity and resistance different. Resistance means resistance of a conductor, but resistivity of that, clear, of that material. Is it clear? Next one is another one is, what is the SI unit of resistivity? Resistivity to ohm meter. How? It is resistance. Resistance is ohm. Already we know that we have discussed. Okay, sorry, I have not told. What is the SI unit of resistance? Resistance is ohm. Area is meter into meter. Divided length means it is meter. Meter will be cancelled. What is left? Ohm meter. This is ohm. This symbol is ohm. Clear? So this is the SI unit of resistance. Clear? Now we will discuss Now we will discuss combination of resistance. How we can combination of resistances. Resistances can be combined in two ways. First one is series, second one is parallel. Second one is parallel. Okay, what is series connection and what is parallel connection? Let us know. Series means two or more resistances fixed end to end. Here one resistor, here another one, here another one, like this. Okay, this is the symbol of resistance. This is another resistance. This is another resistance. Okay, clear? So you can say it is R1, it is R2, and it is R3. Okay, so how we can connect it? It is in a series, end to end. First one, second one, third one. Suppose here the resistance is 2 ohm, here it is 3 ohm, here it is 4 ohm. So what is the total resistance here? Total resistance is equal to, we can find out R is equal to R1 plus R2 plus R3. So how many resistances are there? We can add like this. So R is equal to, we can find out 2 plus 3 plus 4. Okay, 9 ohm. Clear? This is series connection. Next one is parallel connection. What is parallel connection? Parallel connection, in parallel connection, what we are doing is that this is a parallel connection. One resistor, two resistor, second resistor, third resistor, like this. Okay, like this type of connection will be there. This is R1, this is R2, this is R3. Suppose same we will take, this is 2 ohm, this is 4 ohm, this resistor is, let us take 4 ohm. Then how we can find out the total resistance of this circuit? Then we have to write, this is the formula, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. What is R1 here? 1 by R is equal to 2, 1 by 2 plus 1 by 4 plus 1 by 4. Clear? So it is 1 by R. So 1 by R is equal to, we will add this 4 by 4. 1 by R is equal to 1. So R is equal to 1 by R is equal to 1. So R is equal to 1. Reverse. Clear? Like this way, using this formula, we can find out resistance in parallel as well as in combination. Clear? Some devices used to measure. Voltmeter is an instrument used to measure potential difference, and it is always, voltmeter is always fixed in parallel, where ammeter is used to measure current and it is connected in series. Clear? Voltmeter is always, voltmeter to used to measure potential difference, and it is in parallel. We have to remember this. Okay, and while we are connecting voltmeter and ammeter will be, okay, ammeter to current, electric current, and it will be connected always in series. Okay, now heating effect of electric current, we will discuss heating effect. heating effect of heating effect. Heating effect. Okay. Heat energy will generate while charge flow from one end to other end. So energy is equal to power into time. Heating effect, from heating effect energy will generate what type of energy? That is heat energy. Heat energy will be energy is equal to power into energy is equal to power into time. Clear? Power into time. What is power? Power is equal to, already we know that power is equal to, in first equation we discussed, just recall back, VQ by T. Power is equal to VQ by T. Clear? Power is equal to VQ by T. Why? Because I is equal to Q by T. I is equal to Q by T. Clear? H is equal to, look at here, H is equal to, here energy H is equal to power into time. Power is equal to VQ by T. Clear? So P is equal to V into I. P is equal to V into I. Clear? Now I will put here P is equal to V into I. So H is equal to V into I into T. Clear? So this is the formula for H, heat. How much heat energy will generate? We can find out from here. H is equal to Vi into T. Vi T. Clear? According to Ohm's law, V is equal to IR also. Clear? If we will put here, instead of in this equation, suppose we will take this one, equation 1. So what will H here? Put this V is equal to I into R. Then instead of V, what I can write? I into R into I into T. So I into I is equal to I square. So H is equal to I square R T. This is the second formula for heat. Third formula, if we will take I is equal to V by, from here we can take I is equal to, what is I here? I is equal to V by R. Just put this, I is equal to V by R here. Okay, in equation 1 put this value, V into I means V by R into T. So this is equal to V into V is equal to V square by R into T. H is equal to V square by R into T. This is the third one. First one, second one and third one. Clear? For H, heating effect, we can have this formula, V into I into T. This formula, I square into R into T. Sorry. V square by R into T. Third one. Okay. This is also known as Joule's law of heating. This is known as Joule's law of heating. The heat produced in a resistor is directly proportional to the square of the current for a given resistor. It means if we double the current, heat becomes 4 times square. If it will be 3 times, then it will be 9 times. It will become, current will be, if it will be double, then it will be 4 times. If it will be 3 times, then it will be 9. 3 times means it will 9 times because it is square. 2 times means 2 2 j 4. 3 means 3 3 j 9. Like that. This type of question will come. Okay. Directly proportional to the resistor. First one is directly proportional to the square of the current. First one is directly proportional to the square of the current. Second one is directly proportional to the resistance of a given current. That means if we use a wire of nichrome, having more resistance, it produces more heat. If we use resistance like copper, it will produce less heat. Third one is, it is directly proportional to the time for which the current flows through the resistor. If time will increase, it will also increase. If time will decrease, it will also decrease. Clear? This is all about our electricity. I hope that this chapter will be beneficial to you. We will see again, we will meet again. Thank you. Have a nice day.